Hello students, welcome you all to the world of physics. As you know, this channel deals with the physics of ICSE, high school level, class 8, 9 and 10. Every time I'm coming near you with a new concept of physics, new topic of physics. Today, in this video, I am going to do the analysis or I am going to explain you about a topic of physics class 10th ICSE refraction through a lens. In my previous videos, I have discussed that when a ray of light passes from one transparent medium to another, what are the changes occur when it passes through a plane surface. Now, here I will discuss what is the effect of light when it passes through a spherical surface. So, today's topic of discussion is refraction of light through a lens. Lens basically of two type, and in this two type we'll discuss their image form, their uh, other properties related to the lens. So let us start this topic. First thing to know, what is a lens? Lens, most of the time we are using in spec or spectacles, those who are having eye problem. So first let us know what is this lens. Lens is a spherical surface. Lens is bounded by two surfaces and which is a closed surface. One side plane, other spherical also possible. Both sides spherical also possible. And in this lens, again, it is converging the light or it is bringing the light inside or it is taking the light outside. Depending upon that, this lens again divided into two categories or two types of lens. One type of lens is called the convex lens and other is called the concave lens. If we look in this concave and convex lens is thicker in the middle and periphery or outer part if we look is thinner. But in case of concave lens, middle part is thinner but the outer part or peripheral part is thicker. So when we will discuss about this convex lens is a type of lens in which middle part is thicker and thinner is the outer part or peripheral or periphery. And this lens, when a ray of light will incident on this lens or from any source, when the ray of light will come and hit to this lens, it brings the light as inward, or simply you can say it's a converging lens. This lens again having three types depending upon the shape. One type where both the parts are convex, it is called biconvex lens. One side plane, other side convex, called plano-convex lens. And one side concave, other side convex is called concavo-convex lens. Means three type of lens, and all these three types of convex lens are having the property to converge the light rays. Another one type of lens is the concave lens. If you look here, the concave lens having middle part thinner and periphery part thicker, and these light rays take this lens take all the light rays outside, so it is in the category of diverging lens, which diverge the light rays, take the light rays outside. And this lens also of three types. One is the biconcave lens where both the side are concave, one side convex, one side concave is a a convexo concave lens, and one side plane and other side concave is known as plano concave lens. Here we got two type of lens. One concavo-convex, one is convexo-concave. So both the concavo-convex and convex-concave or convexo-concave, both these lens one side concave, one side convex. But if we look the action, concavo-convex lens is thicker in the middle, which bring the light is inside or converging nature. But in case of convexo-concave, the middle part is thinner and its property or its action to take the light is outside of the diverging lens. So when we'll come to, we got what are the types of lens. Now some technical term used in a lens. Lens because it is bounded by two spherical surface or one side plane, one spherical surface. Here we will discuss about the biconvex and biconcave. Means both the sides are spherical. So some technical term used in a lens with their definition. First one, if we look, center of curvature. As we know, in lens we are having two spherical surface. Means both side, if we look, it is form a circle. Means both are having a center. For that, in the center of a sphere of which lens a part is the center of curvature. Because it is having two spherical surface, so it has two center of curvature C1, C2 or 2F1, 2F2. Next one is the radius of curvature. Radius of curvature means from the center to any point in the periphery. Means the radius of sphere of which lens a part is the radius of curvature. So next one is the principal axis. Principal axis, the line which join both the sides, because we are having two spherical surface C1 and C2 will get their center. The line, a straight line joining both the center or C1 and C2 or center of both the spherical surface, that is principal axis. Next, optical center. Optical center usually the point in the lens, nearly the middle point we can say, and any ray of light passing through the optical center remain undeviated for a thinner lens, but in case of a thicker lens, we'll get incident ray, refracted ray, and emergent ray. Next is the focal plane. Focal plane means plane passing through focus, because in a principal axis we'll get two focus, because two spherical surface or two focus will get, what we'll discuss next. And any ray of light, any plane passing through this focus and normal to the principal axis or perpendicular to the principal axis, that is called focal plane. F1 and F2. First, let's discuss about our fast focus. Focus 1 or fast focus or fast focal point. It is that point in a principal axis where light rays starting from any source, in case of a converging lens, they meet at a point. In case of diverging lens, they appears to meet at a point, is called the focus. Focus, one side real focus, one side virtual focus. Or simply we can say, one side when the ray of light incident from a source and meet at a point, F1, and F2 case, it is that point the principal axis or that parallel beam of light converge to a convex lens or diverge to a diverging or concave lens. In case of convex lens, they actually meet at a point, but in case of diverging lens or concave lens, they appears to meet a point. It is second focal point. Means both sides will get one focal point, and from that focal point to optical center is known as the focal length. And from optical center to focus is the focal length, whereas from optical center to center of curvature is called the radius of curvature. Here you can see, in case of in first one, if we look, in case of this first diagram, here F2 in the right side, F1 in the left side. Means any ray of light parallel to principal axis which is coming from right side to the left, right to left, they meet at a point in the left side. For that, even F1 at the left. Any ray of light coming from left side, it intersect or meet at a point on the right side, that is F2. But in case of concave lens, a ray of light coming from right side meet at a point at right, and ray of light coming from left side, they appears to meet a point in the left. For that reason, if we look here, in case of concave lens, F1 always will get in the right side and F2 in the left side. So F1 and F2, two focus of a lens. So now we'll come to the next one, is focal length. Focal length is the distance between focus and optical center. And when we are taking a biconvex lens, that time f1 from O and f2 from O are same. And that case where both sides are equal or same. Next one, here you will see convex lens has real focus because it is a converging lens. Concave lens has the focus virtual because they appears to meet at a point. And whenever we'll take any lens and some part of it is covered by any surface, or it will cover some part of their lens, focal length will not change. We can say that some part of reflecting surface may change, but focal length of the lens will remain constant. And this focal length of lens again depends upon two factors. First factor is a refractive index of the lens, means on which material, because different type of material, different type of transparent medium we are having, on which material we have made this lens, depending upon the focal length, and depending upon the focal length, another the power of lens, what we will discuss in our next video. And radius of curvature of these two lens means if we take a thicker lens, when we are taking a lens with thickness more, it is having the focal length less. Whereas a thinner lens having a focal length more. When we are taking same material, for same material, thicker lens has less focal length, thinner lens has more focal length. Next one here is the rules to draw the ray diagram. What is a ray diagram? Lens form image. One side object will keep, other side will form its image because lens is a transparent object. Lens, through lens, light will refract, will not be reflection of light, will be the refraction of light. So, ray diagram is that where by using certain number of rays, we'll try to find out the image position or where the nature of image formed by any lens. To draw a ray diagram from this lens, we have to follow some rules. If you look here, in case of convex lens, first rule is a ray of light parallel to principal axis after refraction through lens passing through focus. Any ray of light passing through focus after refraction parallel to principal axis, and any ray of light passing through optical center remain undeviated. This one, if we take here, lens is thinner, but if in case of thicker lens, we'll get a refraction of light. So we'll get a incident light, refracted ray, and emergent ray. But we are taking here a thinner lens. For that reason, any ray of light passing through passing through this optical center, going undeviated or passing undeviated is going straight. So here you can see three rules. First one, a ray of light parallel to principal axis after refraction through the lens pass through focus. First law. Second one, any ray of light passing through focus after refraction parallel to principal axis. Third one, any ray of light passing through optical center become undeviated. So next here, to find the image or ray diagram for a convex lens. For concave and convex lens, the rules are same, but in case of convex they actually meet. In case of concave, they appears to meet at a point. For that reason, concave lens every time form a virtual image. In case of convex lens, it can form the real image as well as virtual image. So first one, when the object at infinity means at a very high distance, very large distance, like sun is the object, and we'll place the lens here. That case, if we look here, parallel beam of light when they will hit to the lens, after refraction through the lens, they'll meet at a point focus. Because they are coming from left side, they meet at right, f2. So here you can see the image nature, real, inverted and point. So this application of will look here. Application of this is used as a burning glass, means when all the light will focus in one point, by using a magnifying glass you can burn small piece of paper. Next one, When the object now coming towards the lens and it is beyond 2f1 or c1. Why I will say c1 point h2f1 or c point h2f? Because radius of curvature is a double of focal length. So when the object is placed now, it will look beyond center of curvature. So two light rays, one is parallel to principal, is passing through focus. Second is passing through the optical center mid at a point to form the image whose nature is real, inverted and diminished. And position it will look between F2 and C2. Here I am taking two rays. You can take any other rays also, like a ray of light passing through focus after refraction become parallel to principal. This is our third law. You can use that law also. Any two rules we'll use to find the image formed by a lens. It will come to the uses of this lens. It is used in camera, where in the camera lens it seems to us the image is smaller but object is bigger. And most of the time convex lens form inverted image, but when we are using two lens, that time we'll get the straight image or erect image. So when the object is between infinity and C1 anywhere, it form the image between F2 and C2 with the nature real, inverted, diminished. Next one, when the object now at C1 or 2F1. When the object at C1, two light rays, one is parallel to principal axis passing through focus, other is a ray of light passing through center, optical center, meet at a point which is C2 point, means real, inverted and same size of image form. That's the position of C1 where image form at C2, and the next means other side with the same size. And it will come to its use. It is used in a telescope, terrestrial telescope, mainly to get the same size of image but inverted. Next one, when object is between F1 and 2F1, means between F and C. Again, two light rays will take a ray of light parallel to principal axis passing through focus. Another one, a ray of light passing through optical center, they meet at a point. And here you can see when object is between C1 and F1, image is forming beyond C2. Means here nature it will look, it is real, inverted and enlarged or magnified. And this lens is used in cinema or in slide projector where smaller image seems to us bigger. For that reason in slide projector, slide is given inverted so that we'll get a straight image because it forms inverted image. Next one, when object at F1 at focus point, we know that a ray of light passing through focus after refraction through the lens, it will become parallel to principal axis. So here you can see any ray of light passing through optical center remain undeviated fasting. Second one, a ray of light parallel to principal axis after refraction through the lens passing through focus, and these 2 points are not having any intersection point, means they both will meet at infinite distance infinity, and it form highly enlarged image, real image and inverted one. And its application is it is used in collimator of a spectroscope. Collimator is used to get the parallel beam of light. Spectrometer is used to get the pure spectrum. In my video of pure spectrum, I have discussed what is pure spectrum. For that, you have to subscribe my channel to get some new updates. And it is used in collimator of a spectrometer. Collimator is used to get a parallel beam. Spectrometer is used to give the pure spectrum so that we will able to differentiate between the spectrums. Now, when the object is between F1 and O, means now it is close to the lens, between F point, focus point and lens. Then here you can see two light rays, again same. A ray of light parallel to principal axis after refraction through the lens passing through focus. Second one, a ray of light passing through optical center remain undeviated. But if we look here, both are not having any intersection point. Both are diverging. For that reason, if when you bring them backward, it forms an enlarged image, erect image, straight image of magnified size. So this is used as a magnifying glass Mainly in case of our microscope, we are using this where smaller object seems to us bigger and image from the same side where object is placed. So when the object is between F and O, image form is erect, virtual and enlarged and on the same side of object. Means here we got when object is moving from infinite distance toward the lens, gradually the size of image is changing and first it form some real image. Then when it come very near to the lens, it form a virtual image. Here you can see the movement of object and image in this animation. So we got how a convex lens form image for an object starting from infinity to the optical center. Now for the concave lens. In case of a concave lens, as concave lens is a diverging lens, so it take all the lightest away. Means always will form a virtual image. So let's look how a concave lens form the image. In case of a concave lens, when the object is placed anywhere, or here I am taking a position between C1 and F1. You can take any point. So a first one, a ray of light parallel to principal axis after refraction through the lens passing outside. Here you can see the diverging lens. So it diverges. So we have to take the light rays backward. Second rule, a ray of light passing through optical center remain undeviated. So where the two rays will intersect each other, meet each other, that is the image point. An image, if we look, image and object both are the same side and image size is diminished. Means it form first thing is the virtual image, it form diminished image and it form erect image. An application of this lens equal loop is used in the spec or spectacle for the person suffering from short-sightedness or myopia. Means the person who are having the problem to see the far object, they are using concave lens. But in case of convex lens, because the converging lens is used in a magnifying glass, so the person who are having the problem to see the near object, they are using convex lens. So this is one is convex lens, one is concave lens. For concave lens, here you can see when black color is the object, blue color is the image. When object is moving from its initial position to near the lens, gradually the size of image you can see the changes here. Gradually the image size is changing, but always for the virtual image, erect image, but little bit size is increasing. This is about the concave lens. So in concave and convex lens, we got that one is forming real image, one is forming virtual image. One case when will come from the infinite distance to the lens, gradually size of image increase and last it is forming the virtual image. And in case of concave lens, also size is increasing, but every time it forms a diminished image. If we compare the virtual image formed by a convex and concave lens, virtual image formed by concave lens is diminished. But in case of convex lens, virtual image form is magnified. Both case, virtual image form the same side. And if we take that by touching how we'll be able to know concave and convex lens. Concave lens is having the middle part thinner but outer periphery is thicker. But in case of convex lens, middle part is thicker and outer part is thinner. Means this is all about the concave and convex lens. In my next video, I'll discuss what is lens formula and how we can calculate the image form or image distance, object distance, focal length with sign convention. Thank you.